Okay, it's December the 2nd, and over the weekend I worked on integrating the DC to DC up converter board with the kitchen timer circuitry and the software. And so first of all, this website here, Nick Gammon's website, he has an example of the code that you can use to make something wake up based upon a interrupt. And so using this code, I updated my my program to have a go to sleep function that'll actually put the system into a low power state. And the only trick that I had to do was I'm using a library here, this pin change interrupt library that was preventing the system from going to sleep like it was supposed to. So I had to kind of work around that. But besides that, it went pretty quickly, and I was able to get the software to make the microcontroller go to sleep. And on the circuitry side, I had to do a couple things. First of all, what I did was I broke up the different parts of the kitchen timer into parts that are going to be always powered and parts that can be powered on and off by the microcontroller. So for instance, the DC to DC converter card is plugged into these power rails here, and before I had little jumpers here that would connect these two rails. I removed those jumpers, these little jumpers there. I removed those jumpers so that only power is going to go to this bus here. So this is like the always on bus. And you can see that there's some leads here that are going all the way over to the Arduino development board. So it will always be receiving power from this. And what I did over in these other buses here was I also removed the jumpers so they're not connected, and I ran the negative line over to a transistor. So this is a new part. This is a NPN transistor, and so with this NPN transistor, I'll be able to complete the circuit of this negative line over to this back bus. And to complete the circuit, I've got a control that's going over to the microcontroller. So when the microcontroller goes to sleep, what I can do is send the right signal here to this transistor to actually turn it off. It'll break the circuit, and then power won't go to this bus. So let me show you this in action. So right now I've got the battery pack plugged in to the up converter, and the up converter right now is kind of bouncing around the current that it's drawing. But if I show the max here, so it goes up to about 20 microamps as it's bouncing around, and then and it's also the Arduino development board is in this low power sleep state. And I measured it on its own, and it only draws 0.1 microamps according to this meter here. On Nick Gammon's website, he said that he measured 3.5 microamps, and he's using something much better than this meter. So I don't, I would believe it's drawing 3.5. But anyways, when I turned the knob here, the kitchen timer woke up, and it powered this rear bus here where the LED is connected in this button. And after 7 seconds, I have it go off right now, so I'll just turn it again. So it's actually on, it's running, and I could set a time. If I click it a couple more times, I hit the button, it should beep after like 3 or 4 seconds. So there you go. So it's working as a timer, but then after the 7 seconds, it'll turn itself off. And when it's on, let me go ahead and I'm going to turn the knob. You can see it's drawing 37 milliamps. Switched it there to milliamps. And then in 7 seconds, it'll turn itself off and go back down into that microamp range. So that is really cool. Oh, and the other thing that I also worked on too was learning how to use a diode, which is, there's not much to it actually, but so I've got a little diode right in there, and this is in case the batteries get plugged in wrong, it won't fry anything. So again, if I turn this thing on, you can see it's drawing 37 milliamps. This is without the diode. If I change the circuit here and I put the diode in between the battery pack and one of the leads that's going to the up converter here, and now I'll switch the kitchen timer on. Now it's using 45 milliamps. So that diode causes a voltage drop, and it's causing the kitchen timer to draw a lot more power. So this is just a regular rectifier diode, and there's I learned that there's another diode that's called a Schottky diode that has a lower voltage drop. And the voltage drop of this diode here is pretty significant. It's basically, a good part of one of these rechargeable AA batteries is what it loses in voltage. So this Schottky diode, it only is supposed to drop like 0.2 volts, something like that. So I ordered a bunch of those. It's only like $2.50 free shipping. So they'll be here hopefully by the end of the week. So yeah, that's the diode, and I got a transistor now, which is kind of cool. Oh, yeah. So the 7-segment display and the shift register here are not plugged in because of this interesting quinky dink that I found. So here's the leads here for the shift register, and these leads are only the clock, the data, and the latch. There's no power on these leads, nor is there power on the buses where the shift register and the 7-segment display are connected. I've unpowered the buses. There's nothing going to them. So when I plug this in, this is only the data lines, basically. There's no power going over to that shift register. So I'm going to go ahead and wake up the kitchen timer, and you can see it's drawing over 100 milliamps all of a sudden, and the 7-segment display is showing a bunch of garbage numbers, and as I rotate left and right, you can see it's just showing garbage. So the shift register is being powered by the data lines here. So I wasn't expecting that. I was hoping I could just, unplug the ground for the shift register and it would, turn off everything. So I'm going to have to figure out a workaround and figure out how to actually turn it off, because that's not working. So, but still, good progress, and I'm sure I'll figure out a way to get around this.